There is a moment quiet, fragile, when you look up at the night sky and feel something unsettlingly gentle. The awareness that life on Earth may not be the only story the universe has written. For billions of years, planets have formed, oceans have risen, atmospheres have shifted, and somewhere in that vast cosmic silence, the ingredients for life have gathered and scattered like dust on a distant breeze. Tonight, as you settle into stillness, imagine this: worlds orbiting red suns, covered in pale oceans that breathe in slow tides, planets wrapped in thick violet skies where storms curl like living threads, moons warmed by hidden oceans beneath layers of ice, whispering with chemical reactions that mimic the earliest heartbeat of life. Scientists call it time's habitability, time's the delicate balance where temperature, chemistry, water, and atmosphere align. But beyond habitability lies something more mysterious: the possibility that life could take forms we would not recognize, shapes not built from carbon, voices not carried by air, senses tuned to colors we cannot see. As your mind drifts deeper into calm, imagine an unseen ecosystem, quiet, ancient, untouched by human eyes. Imagine organisms shaped by gravity twice our own, or creatures gliding through methane seas where cold is not an enemy but a cradle. Life that thinks differently, breathes differently, evolves differently, and somewhere, on a world we have never touched, under a star we have never named, there may be a spark, a consciousness, wondering if it, too, is alone. Tonight, we drift toward that thought, toward times the life we haven't met asterisk, toward the soft mystery of worlds that breathe in silence, far beyond our fragile blue home. Across the vastness of the universe, life depends on delicate balances, subtle conditions that must align with extraordinary precision. Temperature, chemistry, atmosphere, and energy flow together like quiet threads, creating the soft fabric from which living systems can emerge. As you let your breath slow, imagine these threads drifting across distant worlds, weaving environments unlike anything on Earth yet governed by the same gentle laws of nature. Scientists speak often of liquid water, the great solvent of biology. But in the silence of space, other solvents may take its place: methane, ammonia, exotic liquids born from cold and pressure. Imagine a world where lakes shimmer in pale gold, not with water but with cold hydrocarbons that move like thick glass under a violet sky. On such planets, life could form slowly, gracefully, shaped by chemistry that feels both alien and familiar. Energy, too, is essential. Here on Earth, sunlight breathes life into oceans and forests. But far from any warm star, energy may rise from within a planet's molten heart, warming icy seas under thick crusts of frozen stone. Picture an ocean hidden beneath a shell of ancient ice, glowing softly with geothermal heat. In that quiet warmth, simple organisms might drift, sense, respond, evolving in absolute darkness. Atmospheres become the softest filter of all, holding heat, carrying molecules, protecting fragile chemicals from the cold emptiness beyond. Some worlds might wear dense blankets of carbon dioxide. Others may hold thin veils of hydrogen that whisper across barren plains. Each atmosphere a unique language, each one a different way for a planet to speak with the life it shelters. And as your awareness settles into a deeper calm, imagine the possibility that life does not merely adapt to its world. It shapes it, changes it, and becomes part of its story. Across billions of years and countless worlds, life may arise wherever the universe whispers the right conditions, quietly, patiently, waiting for someone to discover it. Across the immense canvas of the universe, life depends on a series of delicate conditions that must align with extraordinary precision, forming an environment where chemistry can breathe, molecules can interact, and energy can flow in ways that allow complexity to emerge. As you relax into a slower rhythm, imagine these conditions unfolding quietly across distant worlds, planets wrapped in unfamiliar skies, moons circling ancient stars, each carrying its own soft potential for life. Temperature, pressure, atmosphere, and chemical balance all combine into a quiet, cosmic harmony, creating the possibility that somewhere far beyond Earth, life may be taking shape in ways that are both beautiful and profoundly different from anything we know. Water is often described as the foundation of life, the universal solvent that allows chemical reactions to occur with ease. But as your thoughts stretch gently into the silence of space, imagine planets where water is not the key ingredient at all. Picture landscapes where lakes of liquid methane flow beneath pale, golden skies, moving with slow, glass-like ripples in the cold air. On such worlds, life could build itself from entirely different chemistries, molecules drifting and bonding in ways shaped not by warmth, but by intense cold, forming systems that breathe and evolve in rhythms unlike anything familiar. These environments may seem hostile to human senses, yet in the logic of the cosmos, they are simply another form of possibility. Energy, the quiet heartbeat of all biological processes, does not always come from a star shining overhead. In the darkness of the outer system, far from any comforting sunlight, there exist moons warmed from within by tidal forces and molten cores, worlds where oceans lie hidden beneath thick shells of ice. Imagine sinking slowly through those deep, dark waters, where faint geothermal currents create gentle gradients of heat that could support simple organisms drifting in the shadows. In these silent oceans, metabolism might unfold without light, turning chemical energy into life in a world completely devoid of day or night. This form of existence, though invisible from afar, is fully aligned with the principles that shape life anywhere in the universe. Atmospheres, too, play an essential role in shaping the destiny of a world. They hold warmth, shield delicate molecules, and allow gases to circulate, carrying the breath of a planet across its surface. As your breath slows into an easy rhythm, imagine worlds with thick carbon dioxide, blankets, or hydrogen-rich skies stretching toward unfamiliar suns. Each atmosphere creates its own rules, its own pressures, temperatures, and rhythms, and life that emerges under these conditions must learn to speak the language of its environment. Whether thin or dense, warm or frigid, an atmosphere becomes both shield and catalyst, carving out the silent stage on which alien biology may unfold. The chemistry of a world forms the blueprint of its potential life. On Earth, carbon forms the backbone of biology, but the universe offers a vast palette of elements that could support alternate pathways. Imagine silicon-based structures forming crystalline organisms that grow slowly, layer by layer, responding to subtle shifts in heat and pressure. Or picture ammonia-rich environments where molecules move with a fluidity shaped by cold, crafting forms of life that are quiet, deliberate, and long-lasting. Each chemical landscape writes its own story, and life, if it emerges, adapts to the logic and limits of its surroundings with remarkable precision. And as your awareness drifts deeper into calm, consider one final truth. Life does not merely exist within its environment, it transforms it. On Earth, microbes altered the atmosphere, plants changed the chemistry of oceans, and animals reshaped entire landscapes. In the same way, alien life, no matter how small, simple, or fragile, would leave its own quiet signature on the world that nurtures it. Somewhere, on a distant and silent planet, a subtle chemical imbalance, a faint glow of energy, or a tiny molecular pattern may already be whispering that life has taken hold. And in the soft darkness of the universe, these whispers may be waiting for someone, someday, to discover them. Across the vast reaches of space, astronomers search for signs of distant worlds where life might find a foothold, using delicate measurements and quiet signals that drift across unimaginable distances. As you let your breath settle into an easy rhythm, imagine the faint dimming of a distant star, a tiny shadow passing across its light. This subtle flicker, barely noticeable even to the most sensitive instruments, reveals the presence of a planet orbiting far beyond our reach. Through this method, called the transit technique, scientists can measure a planet's size, orbital path, and sometimes even hints of its atmosphere, all from the soft whisper of starlight. The wobble of a star tells its own story. As a planet orbits, its gravity tugs gently on its host star, causing it to shift ever so slightly in space. These minute oscillations, detected through the Doppler effect, allow astronomers to estimate the planet's mass and understand the gravitational conversation taking place between the star and its companion. As your mind drifts deeper into calm, imagine this gravitational dialogue unfolding over millions of years, a silent dance between celestial bodies, each movement revealing something about the planet's potential to harbor life. Atmospheric signatures become one of the most intriguing clues in the search for habitable worlds. When a planet passes in front of its star, a thin layer of starlight filters through its atmosphere, carrying with it the faint chemical fingerprints of gases such as oxygen, methane, or water vapor. These spectral lines act like quiet messages written in light, offering scientists a glimpse into the chemistry of distant worlds. As you imagine this delicate filtering of starlight, you may sense how even the smallest trace of a molecule can hint at processes that resemble the familiar rhythms of life on Earth. Temperature and distance form another essential layer of this investigation. A planet must reside in a region known as the habitable zone, neither too close nor too far from its star for liquid water to exist on the surface. But this balance is delicate, shaped not only by distance but by atmospheric composition, rotation, and internal heat. Picture worlds bathed in soft red starlight, warmed gently by dim suns, or icy planets that hold warm oceans beneath frozen crusts. Each combination of conditions creates its own potential for biology, writing silent possibilities across the galaxy. Telescopes, both on Earth and drifting quietly through space, gather enormous mosaics of data, piecing together the identities of these distant planets. Some worlds may be covered entirely in oceans, others may be shrouded in dense clouds or wrapped in icy shells. Each discovery expands our understanding of what a habitable world might look like. As you imagine these telescopes collecting light from stars thousands of light years away, you may feel a sense of quiet wonder at the precision required to detect something as fragile as life's potential. And as your awareness settles deeper into calm, imagine the possibility that among these countless distant signals between the dimming of a star, the whisper of a spectral line, and the wobble of a sun, there may already exist the subtle signatures of a world where life has begun. A place where chemistry is stirring, atmospheres are shifting, and ecosystems may be taking shape in silence. Somewhere, hidden in the data, a quiet planet might already be holding the first hints of times the life we haven't met. Asterisk. Across the universe, evolution unfolds according to the rules of physics and chemistry, yet the outcomes can vary in astonishing ways depending on a planet's environment. As you relax deeper into a slow, steady rhythm, imagine worlds where gravity presses more strongly against the ground, shaping life that moves low and wide, with sturdy limbs or flexible, flowing bodies built to withstand constant pressure. On lighter worlds, the opposite might occur, life rising tall and delicate, gliding easily through thin air or drifting weightlessly through vast open spaces. Evolution, governed by the subtle forces of each planet, paints life with strokes that reflect the conditions surrounding it. The chemistry available on a planet plays an equally profound role in how life takes shape. On Earth, carbon forms the backbone of biology, creating complex molecules that support metabolism and growth. But elsewhere, silicon might form the basis of living structures, building crystalline organisms that grow slowly through layers of mineral deposition. As your mind settles into deeper calm, imagine life forms whose skeletons shimmer with translucent geometry, responding to heat and pressure with movements unlike anything familiar. These beings might evolve senses tailored to vibrations or electromagnetic fields, navigating their world not through sight or sound, but through patterns of invisible energy. Atmospheric composition influences not only the behavior of organisms, but their very structure. A dense, oxygen-rich atmosphere might support large, fast-moving life with complex muscular systems, while a methane-rich atmosphere could favor slow, chemical-based metabolisms that conserve energy in extreme cold. Picture creatures gliding through hazy orange skies, their bodies adapted to low temperatures and thick, heavy air, perhaps producing heat through biochemical reactions entirely foreign to Earth. Such atmospheres would shape ecosystems where every form of life is tuned to the rhythm of its chemical surroundings. Light, or the absence of it, becomes another architect of alien evolution. On planets bathed in dim red starlight, organisms might evolve pigments that absorb faint wavelengths, glowing softly as they convert scarce energy into nourishment. In contrast, worlds locked in perpetual darkness, such as underground oceans or buried caverns, could host life that relies entirely on chemical gradients or geothermal warmth. Imagine creatures with no need for eyes, sensing their environment through electrical signals or subtle pressures in the water. In such places, evolution favors efficiency and silence, creating beings that drift in shadows untouched by any sunrise. Predation, cooperation, and competition shape ecosystems just as powerfully on alien worlds as they do on Earth. But the behaviors that emerge might be adapted to entirely different sensory systems. Imagine social structures formed around magnetic communication, where organisms signal through shifting fields instead of sound, or species that communicate through bioluminescent patterns shimmering across their skin, creating living languages woven from light. These methods of interaction, though alien to us, would arise naturally from the interplay between physiology and environment, forming cultures built on senses humanity has never experienced. And as your awareness drifts deeper into calm, consider how evolution may carve out forms of life that surpass our expectations, shapes, behaviors, and intelligences molded by environments utterly different from Earth. Somewhere in the quiet vastness of the cosmos, life may be unfolding along these unfamiliar paths, evolving slowly and silently into a tapestry of existence we have yet to witness. Within these distant processes, hidden in worlds beyond our reach, lies the gentle possibility that nature is far more inventive than we can imagine, crafting lives that thrive in ways we have not yet met. Across distant planets, ecosystems would arise not as replicas of Earth, but as entirely new expressions of environmental balance, shaped by the interplay of energy, chemistry, and climate. As your breath sinks deeper into a calm rhythm, imagine landscapes sculpted by strange winds, alien tides, or long seasons defined by the slow dance of moons and suns. Life emerging in such places would organize itself into communities built on the availability of resources unique to each world, communities that evolve slowly, quietly, and with exquisite sensitivity to their surroundings. Every organism would occupy a role carved by the specific demands of its environment, forming systems as intricate and interdependent as forests, reefs, and tundras on Earth, yet profoundly different in structure and function. Energy flow forms the backbone of any ecosystem, and on alien worlds, its sources might be surprising. Instead of sunlight powering most biological activity, geothermal heat or chemical gradients could fuel entire networks of organisms. Picture ecosystems thriving beneath thick ice layers, where vents release warm, mineral-rich water into vast, dark oceans. Microbial colonies could form the foundations of these food webs, supporting larger organisms adapted to the whispering warmth of underwater vents. As your mind drifts deeper, imagine the slow, deliberate movement of creatures navigating through complete darkness, relying on thermal currents, chemical signals, or faint electromagnetic pulses instead of vision. On planets with extreme climates, ecosystems might structure themselves around cycles foreign to Earth. Imagine a world where seasons last for decades, long periods of intense heat, followed by slow, lingering cold. Life here would evolve strategies to survive extended dormancy or rapid bursts of growth when conditions shift. Organisms might store energy for years, waiting patiently for rare opportunities to feed or reproduce. Ecosystems built in such rhythms would feel almost meditative in their slowness, as though the entire planet breathes in vast, unhurried cycles, shaping life into beings that exist with deep resilience and quiet endurance. Atmospheric chemistry would further sculpt the interactions between species. On a world rich in methane or ammonia, biological processes might rely on chemical exchanges unfamiliar to Earth. Predator-prey dynamics, cooperation, and symbiosis would evolve through sensory modalities tuned to this alien chemistry. Imagine organisms that communicate through clouds of reactive gases released into the air, each chemical blend conveying information about territory, danger, or mating. Such interactions would create ecosystems where communication is woven directly into the environment, forming a chemical language shared by entire communities across a planet's surface. In aquatic alien ecosystems, life might form floating networks or vast drifting colonies that span hundreds of meters, functioning as interconnected organisms or cooperative systems. Picture immense sheets of biological material that gather sunlight, absorb nutrients, and serve as habitats for smaller creatures living within their folds. These living platforms could rise and sink depending on light levels, forming dynamic structures that reshape the seascape over time. Every movement, every shift in currents, would influence the flow of energy and matter across the ecosystem, creating a constantly evolving environment that reflects the subtle balance of life and surroundings. And as your awareness sinks further into quiet, consider how these alien ecosystems might carry their own forms of harmony, soft, slow, interwoven patterns of interaction that reveal the creativity of nature beyond Earth. Somewhere in the universe, worlds may already hold forests of crystal structures, oceans pulsing with bioluminescent creatures, or skies filled with drifting organisms that feed on light or magnetic fields. In these ecosystems, life would not simply survive, it would flourish in ways shaped entirely by their alien landscapes. These distant worlds whisper of possibilities yet unseen, reminding us that the universe may hold countless forms of balance and beauty, waiting gently in the darkness. Across the universe, senses would evolve not according to human expectations, but according to the specific demands of each alien world, shaped by light, atmosphere, magnetic fields, gravity, and chemical landscapes. As your breath settles into a slow and steady rhythm, imagine life on a planet illuminated by a dim red sun, where organisms develop pigments capable of detecting the faintest wavelengths of infrared light. Their vision would not resemble ours. Instead of bright colors and sharp edges, they would perceive gradients of warmth, subtle flows of energy, and the soft shimmer of thermal signatures drifting across the landscape. Every movement, every breath, every heartbeat around them would paint a quiet thermal map of their environment, guiding their behavior with a sense beyond anything we know. Now imagine the opposite, a world locked beneath an unbroken ocean of clouds, where sunlight rarely reaches the surface. Organisms living here might evolve senses built entirely around vibration or pressure, detecting the smallest tremors through dense air or liquid. Life could navigate by reading ripples in the atmosphere, the way Earth's creatures sense sound, forming a three-dimensional picture of their surroundings through an internal symphony of vibrations. As your awareness drifts gently, picture beings who communicate by shaping these vibrations, sending long, slow waves of information through their environment. Messages carried not by spoken words but by rhythmic pulses of movement. Chemical sensing might dominate planets with thick, reactive atmospheres. Instead of vision or hearing, life could rely on the detection of molecular patterns, interpreting subtle changes in chemical composition as signs of food, danger, or social presence. Imagine creatures whose bodies release intricate blends of gases that function as language, with each chemical mixture carrying a distinct meaning. Their world would be filled with invisible messages floating through the air, forming a living network of communication woven directly into the atmosphere. Every gust of wind would shift the conversation. Every storm would rewrite their sensory landscape. On planets with strong magnetic fields, evolution might favor organisms that sense electromagnetic fluctuations. Picture beings who navigate by feeling magnetic lines flowing across the terrain, perceiving them as shimmering corridors of orientation that shift slowly with cosmic cycles. Subtle pulses from a distant star or a nearby moon might appear to them as gentle waves of direction, shaping their migratory paths. As your thoughts soften into the quiet, imagine these creatures communicating through modulated magnetic pulses, forming patterns that function like a language carved from the invisible fabric of their world. Some planets may harbor subterranean or underwater ecosystems where light never reaches. Life in such places would develop senses tuned to gradients of heat, mineral concentrations, or electric fields generated by living tissues. Picture organisms gliding through dark oceans, their bodies equipped with arrays of electroreceptors that read the faint electrical whispers of nearby creatures. These signals would create an intricate map of movement and emotion, an underwater tapestry of presence that replaces vision entirely. Every pulse becomes a sentence, every shift a gesture, forming a sensory language built from electricity. And as your awareness deepens into calm, consider how profoundly different alien senses could be, shaped not by human experience, but by the constraints and opportunities offered by distant planets. Somewhere in the universe, there may exist life that sees through magnetic patterns, hears through pressure waves in dense air, or speaks through chemical trails drifting across alien winds. These senses would create subjective worlds rich with meaning, beauty, and connection. Worlds built from perceptions humanity has never experienced, yet may someday come to understand. The universe holds countless ways to sense, countless ways to know, and countless ways to be alive. Across the cosmic landscape, intelligence would not emerge as a mirror of humanity, but as a natural consequence of the environments and pressures shaping life on distant worlds. As your breath settles into a slow, soothing rhythm, imagine planets where survival depends on navigating extreme climates, unpredictable seasons, or complex resource cycles. On such worlds, organisms capable of anticipating change, forming long-term strategies, or coordinating with others might gradually develop cognitive structures that resemble intelligence. Their minds would grow in quiet layers, shaped by challenges entirely unlike those faced by early life on Earth, yet built upon the same underlying principles of adaptation and response. Communication becomes one of the earliest hallmarks of rising intelligence. On alien worlds, this communication might emerge not through vocal sound but through electromagnetic pulses, shifting colors across the skin, or subtle chemical signals released into the atmosphere. Imagine a species that conveys emotion, direction, and intention through bioluminescent patterns rippling softly along its body, creating conversations made of flowing light. Another species might communicate through precise vibrations in the ground, sending messages across long distances like a living network of tremors. As you drift deeper into calm, imagine intelligence forming around these sensory languages, societies built upon signals we cannot hear or see, but which to them feel intuitive and essential. Problem solving would take forms shaped by the terrain and atmosphere of each world. On a planet with towering crystal formations, intelligent life might evolve an understanding of resonance and vibration long before it grasps physical force, using sound waves to manipulate its environment. In a dark ocean beneath ice, intelligence might develop through the ability to map three-dimensional spaces using electric fields or pressure patterns, forming complex mental models of unseen worlds. As your thoughts soften, picture these beings navigating their environments with sensory abilities so refined that their understanding of space, motion, and structure surpasses anything humans have developed visually. Social intelligence might emerge in places where cooperation is necessary for survival. On planets with scarce resources, species may form intricate alliances, sharing information through constant sensory exchanges. Their group structures could rely on shared memory transmitted through chemical or magnetic signatures, creating communal knowledge passed between individuals almost effortlessly. This shared intelligence might allow entire populations to adapt as a single, coordinated entity, responding to environmental changes with seamless unity. Imagine such societies evolving through collective awareness, where knowledge does not belong to individuals but flows continuously through the group like a softly circulating current. Technological intelligence, if it arose, would reflect the materials and constraints available on each world. On a planet rich in conductive minerals, technology might develop around electromagnetism rather than combustion or mechanical force. In methane-rich environments, tools might be crafted from crystalline lattices that respond to cold in predictable ways. Life existing underwater might build structures from bioluminescent organisms or use temperature gradients for computation and energy transfer. As your awareness continues to drift, imagine these forms of technology glowing softly in alien nights. Innovations shaped entirely by unfamiliar landscapes, yet driven by the same creative impulse that fuels discovery on Earth. And as your mind floats deeper into quiet, consider how alien intelligence, no matter how different in form, function, or sensory experience, would still reflect a universal truth. Intelligence is the universe learning about itself. Somewhere across the vast expanse, minds may be forming thoughts shaped by red suns, icy oceans, or magnetic fields, perceiving reality in ways humanity has never imagined. Their awareness, drifting through distant ecosystems, becomes another expression of life's quiet determination to understand, adapt, and become more than the world that created it. In this possibility lies the soft, profound reminder that intelligence is not unique to Earth, but may be scattered gently across the stars. Across distant worlds, civilizations would emerge not as reflections of humanity, but as intricate responses to the landscapes, climates, and sensory realities that shape the species living there. As your breath falls into a slower, more even rhythm, imagine a planet where seasons last for centuries, requiring long-term planning and deep generational memory. Civilizations here might develop around preservation, patience, and the careful passing of knowledge across vast stretches of time. Their structures, whether physical or social, would be built not for speed, but endurance, shaped by the need to survive the planet's immense cycles. Every decision would be measured against the quiet backdrop of epochs, creating cultures that think in spans far longer than any human lifetime. On worlds bathed in dim starlight or perpetual twilight, civilizations might grow around bioluminescence or electromagnetic signals, using light or magnetic fields as the foundation of architecture, communication, and identity. Imagine cities glowing softly under alien skies, their buildings shaped by organisms that emit shifting colors, functioning as streetlights, artworks, or messaging systems. Roads could be mapped by patterns of light rather than physical lines, while public spaces pulse in rhythmic brightness to synchronize the activities of the beings who live there. As your mind relaxes, picture societies that speak with light, shaping entire cultures around the subtle language of illumination. Civilizations in deep oceans beneath icy shells would form in environments without fire, wheels, or traditional tools. Their technologies might arise from precise control of pressure, temperature gradients, or electrical fields, allowing them to build structures from mineral deposits or manipulate strands of bioluminescent organisms. Navigation would rely on sonar-like pulses or electric signaling, creating a world where sound and electricity function as both tools and expressions of art. Imagine grand underwater halls sculpted through currents, chambers warmed by geothermal heat, and communication networks that ripple through water like soft, glowing webs connecting entire communities. Planets with extreme geological activity could give rise to civilizations that evolve alongside constant danger. Frequent quakes, volcanic eruptions, or shifting crusts would force intelligent beings to build flexible, adaptive structures integrated into the natural environment. Their societies might develop early warning systems based on subtle ground vibrations or atmospheric shifts, with knowledge systems focused on predicting and harmonizing with planetary forces. Technology would emphasize resilience and transformation, creating a culture rooted in constant adaptation rather than stability. In such worlds, the relationship between civilization and planet would be dynamic and intimate, more a partnership than domination. On planets with abundant resources and stable climates, civilizations could flourish into vast networks of trade, communication, and shared creativity. Without the pressure of constant survival, they might invest in exploration, philosophy, and the development of cultural expressions unimaginable to humanity. Imagine grand floating structures drifting across calm seas, or cities suspended in the air through buoyant gases unique to their atmospheres. These societies might create art forms based on gravity manipulation, or music composed through shifts in magnetic fields, forming traditions that reflect senses and materials foreign to Earth. Their civilization would grow like a blossoming ecosystem of ideas, shaped not by necessity but by curiosity and collective imagination. And as your awareness drifts deeper into stillness, consider how alien civilizations would be reflections not of human values but of the worlds that cradle them. Their technologies, beliefs, and social structures would emerge naturally from their planetary homes, each culture a living extension of the environment that shaped its species. Somewhere in the cosmic expanse, there may already exist civilizations whose histories unfold under red suns, beneath frozen oceans, or across landscapes of shifting crystals. In these places, societies bloom quietly in ways yet unseen, reminding us that the universe holds space not just for life, but for countless forms of community, creativity, and meaning. Across the universe, the structure of alien organisms would be shaped by the physical laws and environmental demands of their home worlds, resulting in anatomies unlike anything imagined on Earth. As your breath softens into a calm, steady rhythm, imagine a planet with gravity far stronger than Earth's, where life would evolve with compact, dense bodies built to withstand immense downward force. Limbs might be short and powerful, with broad support structures that distribute weight efficiently, while internal organs could form layered systems designed to function under constant pressure. As your awareness drifts deeper, picture creatures that move slowly but with incredible strength, their entire biology molded by a world that presses upon them relentlessly. On planets with very low gravity, the opposite challenge would arise. Organisms might develop tall, elongated forms with delicate frameworks capable of spanning great distances without collapsing under their own weight. Movement could become graceful and floating, resembling gliding rather than walking. Wings or membrane-like extensions could evolve not for flight, but for gentle stabilization in thin atmospheres. Muscles might become faintly elastic, allowing slow, sweeping motions tailored to environments where even a slight push can propel a body far. In such worlds, biology would appear almost dreamlike, bodies lifted lightly, moving with airy precision shaped by the softness of their environment. Temperature extremes would sculpt alien physiology in remarkable ways. On scorching planets, life might evolve reflective surfaces or crystalline exoskeletons that scatter intense sunlight and prevent overheating. Fluids circulating through their bodies might resist boiling even at extreme temperatures, forming biochemical systems that thrive in heat rather than succumb to it. Conversely, creatures on frozen worlds may rely on antifreeze-like compounds within their cells, preventing ice crystals from forming and maintaining fluidity in bone-chilling conditions. Imagine organisms glowing softly with bioluminescent warmth, their light a byproduct of chemical reactions adapted to unending cold. Atmospheric composition would introduce yet another layer of biological diversity. On planets filled with dense, reactive gases, respiratory systems might resemble chemical filters or complex networks of membranes that separate harmful compounds from those essential for metabolism. Lungs, as humans know them, might be replaced by external structures that absorb atmospheric chemicals directly through the skin or exoskeleton. Picture beings whose bodies shift color as they process the gases around them, acting as living indicators of environmental chemistry. Each breath, or its alien equivalent, would be a carefully balanced chemical transaction, fine-tuned to the surrounding atmosphere. Nutrient cycles on alien worlds could produce entirely novel digestive systems. In environments where energy sources are scarce, organisms might evolve hyper-efficient metabolisms capable of storing energy for long periods or extracting nutrients from minerals, metals, or chemical gradients, rather than organic material. Some life forms may host symbiotic relationships with microorganisms that convert raw elements into usable energy, similar to the way Earth's deep-sea vent communities rely on chemosynthetic bacteria. As your mind relaxes into deeper stillness, imagine these complex internal ecologies functioning like miniature ecosystems within a single organism. And as your awareness drifts further into quiet, consider how alien biology, regardless of its shape, chemistry, or structure, reflects the universal drive of life to adapt, endure, and thrive. Every anatomical form would be a story written in the language of physics and necessity, shaped by conditions as diverse as distant stars and ancient oceans. Somewhere in the vast darkness, there may exist beings with crystalline bones, fluid bodies, or magnetic senses, each one a living testament to the creativity of the cosmos. In their forms, we glimpse the gentle truth that life is endlessly inventive, building itself anew wherever conditions allow, shaping worlds and being shaped by them in return. Across distant worlds, life must find ways to capture and convert energy in order to grow, move, and persist. Yet the methods it develops would depend entirely on the environment from which it emerges. As your breath drifts into deeper calm, imagine a planet where sunlight is scarce, filtered through thick clouds or dim red starlight. Here, photosynthesis might evolve into far more efficient forms, using pigments that absorb wavelengths invisible to the human eye. Organisms could appear dark, almost black, absorbing every available photon with precision. As your awareness softens, picture fields of such beings quietly harvesting faint light, thriving in an environment where energy arrives as a whisper rather than a blaze. On worlds bathed in intense sunlight, energy capture would demand different solutions. Instead of absorbing light, organisms might develop reflective or refractive surfaces that channel excess radiation safely away from vital tissues. Some could even convert extreme ultraviolet or infrared radiation into usable biochemical energy, relying on molecular systems unknown on Earth. Picture beings shimmering with iridescent shields, adapting to a world where light is both nourishment and danger. Their biology might sparkle under alien skies, forming energy pathways refined by centuries of evolution under relentless brightness. In dark oceans beneath frozen crusts, where light never reaches, life would turn to chemical gradients as its primary energy source. Just as Earth's deep-sea vent communities rely on chemosynthesis, alien organisms might harvest energy from reactions involving minerals, gases, or heat rising from a planet's interior. Imagine broad microbial mats clinging to rocky surfaces warmed by geothermal currents, forming the foundation of entire ecosystems built on quiet chemical exchanges. Larger beings may drift slowly through these worlds, consuming chemical-rich plumes or cultivating symbiotic microbes within their bodies, creating intricate cycles of energy beneath endless darkness. Magnetic fields and radiation belts could also serve as unconventional yet powerful energy sources. On planets with active magnetospheres, life might evolve mechanisms to capture the energy of charged particles streaming past the surface. Cells could contain specialized structures that convert magnetic fluctuations into biochemical signals, functioning like biological antennas. As your thoughts glide into slower currents, Imagine organisms glowing faintly with the energy they absorb, communicating through pulses shaped indirectly by the magnetic heartbeat of their world. Some alien environments might enable life to harness thermal gradients with remarkable precision. In places where surface temperature changes drastically between day and night, organisms could develop molecular systems that store heat during the day and release it slowly through metabolic processes at night. Imagine beings whose bodies function as living capacitors, charging in the warmth and discharging in the cold, maintaining balance as they navigate the extremes of their world. Their existence would be a seamless dance between environmental energy and internal stability. And as your awareness drifts deeper into quiet, consider the creativity with which life adapts to the energy available to it, whether through sunlight, chemistry, heat, magnetism, or radiation. Alien organisms would find ways to weave existence from whatever resources their planets provide. Somewhere across the cosmos, there may be life blooming under red suns, thriving in frozen oceans, glowing beneath magnetic storms, or feeding on the volatile chemistry of distant worlds. These beings, shaped by the subtle interplay of physics and necessity, remind us that life is endlessly resourceful, always finding ways to endure, expand, and illuminate the darkness. Across distant planets, behavior would arise not from familiar instincts but from the subtle demands and opportunities presented by each environment, forming patterns of survival molded over millions of years. As your breath deepens into a slow, soothing rhythm, imagine life evolving in a world where day and night last for months at a time. Organisms here might adopt long cycles of movement and rest, emerging for brief bursts of activity during periods of light and retreating into energy-conserving states during extended darkness. Their behavior becomes a quiet mirror of their planet's rhythm, slow, deliberate, and shaped by the grand sweep of celestial cycles that dictate their survival. On planets with volatile climates, behavior might center around constant vigilance and rapid response to change. Species could evolve complex migration patterns that span entire continents, moving in synchrony with shifting winds, seasonal storms, or tidal flows. Imagine beings that sense atmospheric pressure changes long before they occur, reacting instinctively to distant tremors or subtle temperature shifts. Their lives would be a continuous dance with the instability of their environment, each choice driven by a deep, ancestral memory of survival in a world where conditions shift without warning. Where resources are scarce, behavior could evolve toward extreme efficiency and cooperation. Organisms may form communal groups that share food, protect one another, and coordinate movement through intricate signaling systems. Picture species communicating through patterns of light or chemical trails, pooling their sensory information to form a collective understanding of the landscape. Their social structures could rely on shared roles and distributed responsibilities, creating a system where each individual's survival depends on the success of the group and where cooperation becomes as essential as respiration. Predation on alien worlds would follow its own logic, shaped by sensory systems and environmental conditions that differ widely from those on Earth. On planets cloaked in darkness, predators might hunt using vibrations or electric fields, tracking the faint signatures of prey moving through water or air. In bright, open environments, predators could rely on extreme speed, camouflage that mimics unusual geological patterns, or luring behaviors that exploit rare environmental cues. As your thoughts drift into stillness, imagine these silent interactions unfolding across alien landscapes, each movement precise, each strategy crafted by evolution's quiet patience. Mating behaviors would be equally diverse, molded by the biology and sensory experiences of each species. On worlds with dense atmospheres, elaborate displays of light or sound might become the core of courtship rituals, with organisms generating intense bursts of color or low-frequency vibrations to attract partners. In chemically rich environments, courtship might occur through the release and interpretation of complex scent patterns that carry information about health, compatibility, and readiness. Each ritual, whether visual, auditory, magnetic, or chemical, becomes its own language, a series of gestures through which life continues its lineage. And as your awareness sinks deeper into calm, consider the profound variety of behaviors that could emerge across alien ecosystems. Somewhere in the universe, there may be creatures that forage in shifting dunes beneath red suns, others that glide through methane seas following ancient migratory paths, and still others that drift silently through dark oceans guided by electrical whispers. Each behavior tells a story of adaptation, a testament to life's endless ability to interpret, respond to, and harmonize with the world around it. In these distant patterns of movement and interaction, we glimpse the infinite creativity with which the universe shapes its living forms. Across the universe, communication would arise from the same fundamental need that shapes all living systems: the desire to exchange information in order to survive, reproduce, and form connections. But the ways in which alien species accomplish this would depend entirely on their sensory tools and environmental conditions. As your breath drifts into deeper calm, imagine a world where light is scarce and sound travels slowly through dense air. In such places, species might develop communication based on chemical trails, each molecule carrying subtle variations that indicate danger, food, territory, or social status. These chemical signatures would form intricate, drifting messages that linger in the environment, transforming the air itself into a woven archive of information. On planets bathed in bright, stable starlight, communication might evolve around visual patterns, shifts in color, texture, or shape that convey meaning with astonishing precision. Picture beings whose skin functions like a living canvas, changing hues in fluid waves to express emotion, intention, or warning. An entire conversation could unfold across the surface of a body, each color transition forming part of a dialogue visible to all present. Such communication would be immediate and expressive, a language of light shaped by evolution to thrive in open, illuminated environments where visibility is constant and vibrant. In underwater or subterranean worlds, sound and vibration become more reliable than light. Life could use complex sequences of pulses, clicks, or pressure waves transmitted through dense mediums to communicate across great distances. Imagine species that generate vibration patterns with specialized organs, allowing them to encode detailed information in the rhythm and frequency of each signal. As your awareness softens further, picture vast underwater networks where messages ripple through dark oceans, forming a silent symphony understood by every organism attuned to its gentle movements. Magnetically active planets might give rise to communication systems based on electromagnetic fields. Some species could evolve biological structures capable of generating or detecting subtle magnetic fluctuations, using them to share information without relying on sound or light. Imagine beings that send pulses through the atmosphere, forming invisible pathways of communication that pass effortlessly through obstacles. These magnetic signals could carry layers of meaning, emotional tone, direction, urgency, forming a language completely silent yet immensely powerful, shaped by the invisible architecture of the planet's magnetic environment. In more extreme environments, communication might rely on biochemical luminescence, a form of light generated by living tissues. Species could express themselves through shifting patterns of glow, intensifying or softening their brightness in response to environmental cues or social interactions. Picture entire forests of bioluminescent organisms pulsing softly in synchronized communication, their patterns rippling through the darkness like living constellations. In such worlds, communication becomes not just an exchange of information, but a visual expression of connection that transforms the landscape into a canvas of shimmering signals. And as your awareness drifts deeper into tranquility, consider how alien communication, no matter how foreign its form, would achieve the same universal purpose, creating bridges between living beings. Somewhere beneath distant suns, species might speak in chemical blends, glowing patterns, magnetic pulses, or harmonic vibrations. Each method reflects the unique constraints and opportunities of its world, forming systems of extraordinary creativity and complexity. In these silent conversations flowing across alien landscapes, we are reminded that communication is an essential expression of life, one that binds individuals to one another and shapes the hidden stories of worlds we have not yet seen. Across the boundless variety of worlds scattered through the cosmos, alien life would face environmental challenges far different from anything found on Earth, forcing organisms to evolve adaptations that reflect the harsh realities of their surroundings. As your breath eases into a gentle, steady rhythm, imagine planets where storms last for decades, sweeping across continents with winds strong enough to grind rock into dust. Life here might develop protective exoskeletons or flexible, shock-absorbing tissues capable of withstanding relentless turbulence. Movements would be slow and deliberate, anchored against forces that reshape the terrain itself. As your awareness deepens, picture creatures leaning into these storms with practiced resilience, their entire physiology shaped by the need to endure atmospheric chaos. Elsewhere, intense radiation from a nearby star might be the defining challenge. Organisms on such planets could evolve pigments or molecular shields that absorb harmful particles, converting them into harmless forms of energy or dissipating them through specialized biological structures. Picture beings whose skin shimmers with reflective patterns, functioning as both armor and energy regulator. Over time, these adaptations could form complex patterns that help identify individuals or signal social status, turning survival traits into the foundation of entire cultural systems. Radiation would not merely threaten these beings, it would sculpt their biology and behavior with quiet inevitability. On worlds dominated by extreme temperatures, life would take paths shaped directly by thermal stress. In blistering heat, organisms may develop cooling mechanisms such as internal fluid circulation, heat-reflecting surfaces, or metabolic systems that operate efficiently under scorching conditions. In contrast, life in frigid environments might rely on antifreeze-like compounds, insulating outer layers, or slow metabolic processes that conserve energy. Imagine a frozen world where creatures move with graceful patience, their internal chemistry tuned to remain fluid in temperatures far below freezing. As your thoughts soften, picture these beings thriving in silence, each adaptation a testament to the persistence of life under unimaginable cold. Some planets may be covered in oceans of ammonia, methane, or other reactive liquids that pose chemical dangers to living tissues. Life would need to evolve protective membranes or biochemical pathways capable of neutralizing or harnessing these substances. Imagine organisms with layered skins that change composition in response to environmental chemistry, transforming harmful compounds into usable nutrients or harmless byproducts. Entire ecosystems could arise from creatures that feed on chemical reactions themselves, forming intricate webs of survival built on interactions invisible to the human eye. In these alien seas, danger becomes a resource, an opportunity written into the logic of evolution. Geological instability presents another extreme challenge. On planets with violent tectonics, frequent earthquakes, or active volcanoes, life might develop heightened sensory perception to detect subtle tremors or pressure shifts. Burrowing mechanisms, rapid relocation strategies, or migratory patterns tied to seismic activity could evolve as natural responses. Picture species that read the language of shifting ground, moving in harmony with a planet's deep, restless heartbeat. Over time, their behavior and social structures might revolve entirely around understanding and predicting geological cycles. And as your awareness sinks even deeper into calm, consider how alien life, regardless of its form or origin, would find ways to survive amid these dangers. Evolution would sculpt beings that reflect the challenges of their worlds, creatures hardened by storms, shielded against radiation, adapted to chemical extremes, or synchronized with seismic rhythms. Somewhere across the universe, life persists, not despite adversity, but because evolution transforms every danger into an invitation for creativity. In these adaptations, quietly unfolding on worlds we have yet to see, lies the enduring truth that life is both fragile and resilient, shaped endlessly by the environments that cradle it. Across distant planets with unfamiliar climates and chemical landscapes, relationships between organisms would evolve into intricate systems of balance, conflict, and cooperation that reflect each world's unique pressures. As your breath settles into a slow, even rhythm, imagine ecosystems where life forms develop deep interdependence, forming symbiotic bonds that allow them to survive challenges no single organism could endure alone. One species might provide chemical nutrients harvested from exotic minerals, while another offers protection with hardened structures or defensive secretions. Together, they form alliances shaped by necessity, creating networks of shared survival that echo through alien habitats. In some worlds, competition might dominate, sculpting species into forms refined by constant struggle for resources. Imagine vast deserts on distant planets where water or chemical equivalents occur only sporadically, forcing species to compete intensely whenever these rare opportunities arise. Organisms could evolve acute sensory systems to detect traces of nourishment or rapid metabolic responses that allow them to store energy for long periods. As your awareness drifts deeper, picture these beings moving with calculated precision, their behaviors shaped by the relentless dance of scarcity and opportunity that defines their existence. Yet cooperation may emerge in environments with unpredictable conditions, where survival depends on collective action rather than individual strength. Entire species might migrate together during planetary cycles, coordinating their movements through chemical or electromagnetic signals. Imagine organisms traveling in synchronized formations across methane plains or frozen oceans, each one contributing a small but essential piece to the collective survival strategy. In these worlds, societies arise not from dominance but from harmony groups functioning as unified organisms, their fates entwined across the expanse of alien terrain. Mutualism could become especially complex in ecosystems where resources are distributed unevenly. One region of a planet might contain rare minerals necessary for metabolism, while another holds biological compounds required for reproduction. Species inhabiting these different areas could form trading relationships, exchanging nutrients or chemical cues through intermediaries or mobile carriers. Imagine networks of creatures that serve as biological couriers, transporting essential materials between distant territories. Their movements become the lifeblood of entire ecosystems, stitching alien biomes together with silent precision. Predator-prey interactions, though shaped by universal evolutionary forces, would take on unique forms driven by alien sensory systems and environmental structures. On worlds cloaked in darkness, predators might rely on electric field detection or subtle gravitational variations to locate prey. Prey species, in turn, could evolve reflective scales or chemical cloaks that distort the predator's sensory perception. As your thoughts drift into deeper calm, imagine these interactions unfolding in slow, deliberate sequences, an evolutionary interplay far more intricate than anything Earth has seen, crafted by the physics and chemistry of distant planets. And as your awareness sinks fully into stillness, consider how these ecological relationships, symbiosis, competition, cooperation, form the quiet architecture of alien life. They reveal how organisms adapt not only to their environments but to one another, weaving a tapestry of connection across every corner of a world. Somewhere beneath unknown stars, ecosystems may already be thriving in these complex patterns, their lives interlinked in ways both familiar and profoundly foreign. In these invisible relationships lies a reflection of the universal truth that life, no matter where it arises, is shaped by the need to coexist, endure, and grow within the vast and silent cosmos. Across distant worlds, illuminated by unfamiliar suns, climate cycles unfold in patterns shaped by orbital rhythms, axial tilt, atmospheric density, and the gravitational pull of nearby moons. As your breath settles into a soft, steady flow, imagine planets where seasons stretch across decades, with long summers bathing the landscape in warmth and equally long winters plunging everything into frigid stillness. Life here would adapt to the slow heartbeat of the planet, evolving strategies that mirror these immense cycles. Some organisms might grow rapidly during warm eras, producing energy stores to endure decades of cold, while others enter dormant states, waiting patiently for environmental conditions to shift once more. On worlds with dramatic axial tilt, the extremes of light and darkness could shape every aspect of life's behavior and biology. Imagine a planet where one pole experiences continuous daylight for years, while the opposite lies in near-permanent darkness, creating ecosystems shaped by stark asymmetry. Species living in the illuminated zones might evolve protective pigments or reflective surfaces to manage intense radiation, while those on the dark side develop heightened senses for detecting heat, vibration, or chemical cues. As your awareness drifts into deeper calm, picture vast migrations spanning continents as species follow the slow march of light across the planet's surface. Atmospheric cycles would influence alien life just as profoundly. On planets with dense, storm-filled skies, weather patterns might grow to unimaginable scales, storms spanning entire hemispheres, circulating for centuries at a time. Life would need to synchronize with these colossal atmospheric engines, developing behaviors and structures to withstand relentless winds or to take shelter in quiet zones created by the planet's rotation. Some species could even use these storms to their advantage, riding powerful air currents to distant regions or harvesting electrical discharges as a form of energy. Each adaptation becomes part of an intricate conversation between organism and atmosphere. Water or its chemical equivalent would follow unique cycles on each planet. In some worlds, Methane or ammonia might evaporate and fall as rain, shaping rivers, lakes, and oceans that form the backbone of alien ecosystems. Imagine creatures adapted to seasonal chemical floods, capable of shifting their metabolism depending on the composition of the falling liquid. In others, water may freeze for centuries before melting during brief warm periods, prompting bursts of biological activity that fill the landscape with rapid growth and reproduction. As your thoughts soften further, picture these cycles carving patterns of existence that unfold across enormous spans of time. Tectonic activity plays its own quiet role in shaping climate. On planets with active geological systems, volcanic eruptions could darken skies, release new atmospheric compounds, or reshape coastlines in mere moments. Life in such worlds would evolve resilience and flexibility, forming ecosystems capable of recovering quickly from sudden upheavals. Organisms might develop dormant stages triggered by seismic signals, allowing them to survive catastrophic events and re-emerge once stability returns. In these dynamic environments, adaptability becomes the defining trait of survival. And as your awareness drifts deeper into stillness, consider how alien life, no matter its form, would be intertwined with the climate cycles of its world. Each species would carry the imprint of storms, seasons, and geological rhythms in its physiology and behavior. Somewhere beneath distant stars, life may be unfolding in perfect synchrony with cycles unlike anything on Earth, adapting to patterns written in the language of orbital motion and cosmic tides. In these slow, majestic rhythms lies the quiet truth that every world shapes its life, just as life shapes the world, forming a timeless dance across the vastness of the universe. Across distant worlds, shaped by unfamiliar suns and ancient geological rhythms, the evolution of life unfolds over immense spans of time, sculpting ecosystems in ways that reflect the shifting conditions of each planet. As your breath eases into a slow, steady calm, imagine a world where early life begins in shallow chemical seas, forming simple organisms that drift quietly on gentle currents. Over millions of years, these organisms interact, mutate, adapt, and diversify, gradually giving rise to new forms capable of surviving in more complex environments. Evolution becomes a slow, persistent force, guiding life from simplicity to sophistication, carving each biological step with the patience of eras measured not in years but in cosmic cycles. On planets with fluctuating climates, evolutionary pathways might branch in dramatic and unpredictable directions. Species that thrive during warm epochs could decline during long freezes, while cold-adapted organisms rise to dominance, only to be replaced again when temperatures shift. Imagine lineages diverging and converging based on these slow planetary rhythms, creating a biological tapestry woven from cycles of expansion and retreat. Some organisms may specialize intensely, adapting to narrow environmental niches, while others develop broad resilience that allows them to endure repeated planetary transformations. As your mind drifts deeper, picture this ebb and flow of life unfolding like a quiet biological tide. Geological processes would shape the evolutionary timeline with powerful, sudden events. Volcanic activity could generate new landmasses, opening pathways for colonization, while asteroid impacts might trigger mass extinctions that reset entire ecosystems. Life on these planets would respond with incredible flexibility, evolving traits that allow rapid adaptation to catastrophic change. Imagine environments where extinction and emergence are intertwined, where species rise quickly to fill empty niches left by vanished predecessors, creating bursts of diversification that redefine the biology of a world. Evolution becomes both destructive and creative, sculpting life through cycles of loss and renewal. Atmospheric changes would further influence evolutionary trajectories. In worlds where atmospheric composition shifts over millennia, organisms would adapt to new chemical balances, developing metabolic pathways capable of processing novel gases or thriving at different pressures. Picture a species that begins its history breathing one atmospheric blend, but over time evolves entirely new respiratory structures as the planet's skies change color and density. These transformations create layers of biological history written into the anatomy of every organism, reflecting not only their present environment, but the ancient worlds from which they descended. Continental drift, or its alien equivalent, would reshape ecosystems across geological timescales. Land masses might collide, split apart, or drift into new climatic zones, forcing species to migrate, adapt, or perish. As your awareness softens into deeper stillness, imagine vast migrations unfolding across continents that shift slowly over millions of years, guiding life from one ecological domain to another. New ecosystems would emerge where terrains collide, creating opportunities for hybrid species, novel food webs, and unexpected alliances between organisms that once lived worlds apart. Evolution becomes a dynamic map etched into the shifting crust of alien planets. And as your mind drifts into quiet, consider the profound truth that life on distant worlds would not remain static, but transform continuously in harmony with its environment. Every species, every ecosystem, every evolutionary branch would echo the history of the planet that shaped it. Somewhere across the expanse of the cosmos, life may already be weaving its own ancient story, rising, falling, adapting, and evolving with the rhythm of time, creating worlds rich with biological wonder. In these vast evolutionary arcs, we glimpse the timeless interplay between life and planet, a cosmic partnership unfolding silently over billions of years. Across the vast reaches of the cosmos, the search for life hinges on delicate clues, subtle signatures written into the chemistry, light, and motion of distant planets. As your breath settles into a calm and steady rhythm, imagine astronomers studying the faint glow of exoplanets orbiting distant stars, analyzing tiny shifts in color and brightness that reveal the secrets of alien atmospheres. When a world passes in front of its sun, starlight filters through its air, carrying information about the molecules suspended within. These spectral fingerprints, though nearly invisible, offer profound hints about whether the planet's chemistry might support life, guiding scientists toward worlds where biology may already be unfolding quietly. One of the most compelling signs of life is chemical disequilibrium molecules present together in ways that should not persist without biological activity. On Earth, for instance, oxygen and methane coexist in our atmosphere because living organisms continuously replenish them. As your awareness softens further, imagine finding similar imbalances on distant planets. Oxygen mixed with unfamiliar gases, methane appearing in seasonal cycles, or complex organic molecules drifting gently through alien skies. These quiet chemical deviations from expected patterns may serve as the universe's subtle way of whispering that life is present, even if it remains unseen. Surface features can also hint at the presence of life. On some worlds, color variations might indicate biological colonies growing across landscapes, absorbing specific wavelengths of light. Imagine vast regions of a planet glowing with pigments tuned to distant suns, reds, purples, or deep blues shaped by alien photosynthetic processes. On icy planets, strange flows or fractal textures forming along cracks in the surface could suggest subsurface ecosystems interacting with the crust. As your thoughts drift deeper, picture these features revealing themselves through telescopic imagery, each one offering a silent invitation to look closer. The behavior of a planet's atmosphere over time can provide additional clues. Seasonal changes in gas concentrations, shifting cloud patterns, or unexpected temperature variations might reflect biological cycles rather than purely geological or atmospheric processes. Imagine a world where atmospheric chemicals rise and fall in sync with long cycles of growth and dormancy, forming a planetary rhythm reminiscent of blooming and fading forests. Detecting these repeating patterns could guide scientists toward planets where life adapts to local seasons or tidal forces, creating a signature that resonates across years or centuries of observation. Thermal emissions, subtle variations in heat radiating from a planet's surface, can reveal non-random structures or patterns that hint at biological processes. On some worlds, life may cluster in regions warmed by geothermal vents or illuminated by constant starlight, creating temperature anomalies visible across vast distances. As your mind continues to drift, imagine researchers mapping these thermal variations and discovering configurations too organized to be explained by geology alone. In these patterns, the potential fingerprints of living systems may appear, faint yet unmistakable in their coherence. And as your awareness sinks deeper into stillness, consider how these signals, delicate and distant, form the foundation of our search for life beyond Earth. Somewhere among the shifting spectra, atmospheric rhythms, surface anomalies, and thermal signatures lies the quiet evidence of biology worlds where life breathes, grows, transforms, and leaves its mark upon the planet that shelters it. These signs, scattered across the universe, remind us that life does not hide in silence. It reveals itself through the subtle language of its environment, waiting for curious minds to listen. Across the silent expanse of the universe, the presence of advanced civilizations may reveal itself not through direct contact, but through the faint traces of technology, subtle imprints written into the light, heat, and structure of distant worlds. As your breath flows into deeper calm, imagine scientists scanning the skies for patterns that do not arise naturally, energy emissions that fluctuate with artificial regularity, unusual wavelengths that hint at engineered processes, or brief flashes of structured signals pulsing across the stars. These technosignatures, though delicate and easily lost in cosmic noise, could be the quiet messages of civilizations existing far beyond our reach, their technologies echoing through space like distant memories carried on starlight. Some of the most intriguing possibilities involve megastructures, vast constructs orbiting stars to harvest energy on unimaginable scales. A Dyson sphere or swarm, for instance, would alter the light profile of its star, dimming certain wavelengths or producing excess infrared radiation. As your awareness softens, imagine astronomers observing a star whose brightness shifts in ways no natural process can explain, hinting at the presence of engineered structures absorbing and re-emitting light. Such anomalies could serve as the cosmic fingerprints of civilizations that have long since mastered their planetary resources and expanded into the realm of stellar engineering. Other technosignatures might arise from artificial illumination. On distant planets, cities or large-scale industrial regions could emit faint but detectable light during the night side of their orbit. Imagine a world where glowing networks trace coastlines, valleys, or geometric layouts patterns too orderly to be geological. Even from light years away, such luminosity could stand out against the natural darkness, offering a quiet suggestion of technological life shaping its environment with intention and structure. As your thoughts deepen into stillness, picture telescopes capturing these tiny glimmers, each one a potential beacon from a distant civilization. Atmospheric anomalies can also reveal technological activity. Industrial processes may produce gases that do not occur naturally or exist only in quantities that cannot be explained by biological or geological mechanisms. Picture a planet with slight traces of chlorofluorocarbons or other synthetic molecules drifting through its sky compounds that, on Earth, are created solely by intelligent beings. Their presence would suggest the subtle imprint of an advanced society, perhaps one that has harnessed chemistry to shape its world. These atmospheric signatures become quiet whispers of civilization, carried in the thin veil of air that surrounds a distant globe. Radio waves and electromagnetic bursts represent another powerful clue. Although many civilizations might evolve communication systems unlike our own, structured radio emissions remain one of the most detectable forms of artificial signals. Imagine scientists picking up rhythmic pulses too organized to be natural, too complex to be random, drifting across the cosmos. These patterns could indicate communication, navigation, or even long-range beacons left behind by ancient civilizations as markers of their presence. As your awareness continues to drift, imagine these signals as faint threads connecting minds across unimaginable distances. And as your consciousness settles into deeper calm, consider how the universe may already be filled with such signs, technological echoes of civilizations that rose, flourished, and perhaps faded long before humanity's story began. Their structures, light, emissions, and signals may still linger in the cosmic tapestry, waiting patiently to be recognized. In these potential techno-signatures lies the profound possibility that intelligence has blossomed not just on Earth, but throughout the stars, each civilization leaving behind delicate traces of its existence, like small lanterns glowing in the vastness of night. Across the silent expanse of the cosmos, civilizations that rise on distant planets would not only master survival, but eventually seek ways to express their existence, shaping art and culture from the raw materials of their world. As your breath falls into a deep, slow rhythm, imagine beings on a methane-rich moon, creating patterns not with pigments or carvings, but with shifting chemical vapors that disperse in the atmosphere. Their art might unfold in drifting clouds of color and scent, forming intricate temporary sculptures that dissolve slowly into the sky. Culture here would be practiced not on solid surfaces but in the air itself, shaped by the gentle interplay of chemistry and wind, a living expression that mirrors the ephemeral nature of their environment. On a world illuminated by crimson suns, inhabitants might create art through the manipulation of light itself. Imagine species capable of producing bioluminescent displays across their bodies, choreographed like flowing symphonies of color that ripple through entire communities. Their performances could blend movement, emotion, and communication in ways that blur the boundaries between art and language. As your awareness deepens, picture gatherings during long twilight hours where thousands of beings illuminate a dark valley with synchronized waves of radiance, forming a spectacle that transcends any human understanding of visual expression. Cultures residing in submerged oceans beneath icy crusts would create art shaped by fluid dynamics and pressure. Their sculptures might be vast mineral formations grown intentionally near geothermal vents, engineered through chemical signals rather than physical tools. Music, if it exists here, may be crafted from low-frequency vibrations that travel great distances in dense water, resonating through entire communities like a shared heartbeat. Imagine beings composing auditory landscapes, long, layered tones drifting through dark seas, weaving stories carried by pressure waves instead of spoken words. In civilizations that evolve with heightened electromagnetic senses, artistic expression could take the form of shifting magnetic fields sculpted into complex patterns. Beings might gather to create collective displays, threading electromagnetic strands through the air like invisible tapestries that only they can perceive. Their cultural heritage could be encoded in magnetic harmonies, passed down through generations not as written symbols but as spatial patterns recorded in the very structure of their environment. As your thoughts soften further, imagine these invisible artworks radiating gently through alien landscapes, shaping cultural identity with quiet elegance. Some alien societies might develop storytelling traditions unlike anything on Earth, shaped by their sensory limitations and strengths. On a planet where vision is impossible, stories could be told through tactile sequences, patterns traced across the skin with careful precision. In worlds dominated by chemical signals, narratives might unfold through evolving scents that represent memory, emotion, or myth. Each shift in aroma conveys a new chapter, turning storytelling into a multisensory experience woven directly into the atmosphere. Culture becomes a shared perception, a collective journey through time, preserved not in books but in sensations that move through air, water, or skin. And as your awareness drifts deeper into a soft, soothing quiet, consider how art and culture on alien worlds would reflect not only creativity but identity, allowing life to express its place in the cosmos through forms shaped entirely by its environment. Somewhere in the vastness of space, civilizations may already be painting with magnetic fields, sculpting with minerals, singing through pressure waves, or weaving stories through fragrance and light. In these expressions lies the reminder that culture is universal. Wherever minds evolve, the desire to create beauty follows, growing gently from the essence of life itself. Across distant planets, orbiting unfamiliar stars, the evolution of intelligent life would naturally give rise to complex social structures shaped by biology, environment, and the unique challenges each world presents. As your breath deepens into a slow, tranquil rhythm, imagine societies formed by beings whose senses differ profoundly from ours, creatures that perceive the world through electromagnetic pulses, vibrational fields, or chemical gradients. Their social hierarchies might reflect these sensory foundations, with leadership roles assigned to individuals who excel at navigating complex informational networks, reading environmental cues, or interpreting subtle changes in planetary cycles. In such civilizations, authority could emerge not through physical dominance, but through heightened perception and collective trust. On worlds where survival depends on cooperation, social systems might develop around communal living and shared responsibilities. Imagine a species that thrives only when groups act in perfect coordination, forming living networks whose members specialize in distinct tasks: builders, navigators, protectors, or knowledge keepers. These roles could be biologically ingrained, shaped by evolutionary pathways that predispose individuals to certain behaviors or strengths. As your awareness softens, picture cities that function less like human settlements and more like vast, interconnected organisms, with each individual contributing a vital piece to the community's rhythm and stability. In environments marked by scarcity, competition could strongly influence social order. Civilizations might form intricate hierarchies where status is determined by resource management, environmental mastery, or the ability to withstand extreme conditions. Imagine societies living on planets with limited habitable regions, narrow belts of warmth, or chemically stable zones where access to these regions shapes influence and power. But even here, social systems would evolve beyond simple dominance, developing complex negotiations, alliances, and cultural rituals that ensure long-term survival. The struggle for stability becomes a shared narrative woven through generations. Some alien civilizations may be shaped by biology that allows for shared consciousness or collective memory. Species capable of connecting through neural, chemical, or electromagnetic exchanges could create societies where individuality blends into a unified intelligence. Decision-making might occur instantaneously, diffused across countless minds that synchronize like a single living system. As your thoughts drift deeper into calm, imagine a culture where conflicts dissolve into shared understanding, where creativity emerges from the harmonious blending of perspectives, and where progress is guided by a collective wisdom that evolves continuously with each generation. On other worlds, social structures may develop around longevity or life cycles. Civilizations with extremely long-lived individuals might build societies where elders accumulate vast layers of experience and shape cultural continuity for millennia. Alternatively, species with rapid reproductive cycles might create dynamic, ever-shifting social orders that adapt quickly to environmental changes. Picture civilizations where knowledge is encoded not only in memory, but within biological traits, passed down through accelerated evolution. Social organization becomes fluid, changing with each generation as new adaptations emerge. And as your awareness sinks fully into stillness, consider how diverse and intricate alien social systems might be reflecting not only the biological foundations of their creators, but the landscapes, climates, and cosmic rhythms of their worlds. Somewhere across the universe, civilizations may already be flourishing in ways that transcend human imagination. Societies guided by electromagnetic senses, united by collective consciousness, structured by environmental imperatives, or shaped by evolutionary strategies unfamiliar to Earth. In these potential social architectures lies the enduring truth that intelligent life, wherever it blooms, crafts not just bodies or tools, but entire worlds of meaning and connection. Across distant planets, shaped by unfamiliar gravity, atmospheric density, and terrain, the ways in which alien beings move and travel would reflect the deep interplay between biology and environment. As your breath softens into a gentle, quiet rhythm, imagine a world where gravity is only a fraction of Earth's, allowing creatures to glide with effortless grace across vast distances. Their limbs might stretch into elegant structures that capture wind currents, enabling slow, soaring travel above plains of glittering mineral dust. With each movement, they would rise and fall like drifting petals suspended in a silent, weightless dance. Over time, entire cultures might emerge around this natural flight, shaping architecture, communication, and even ritual around the freedom of the sky. On planets with crushing gravity far greater than Earth's, movement would take on an entirely different form. Organisms might evolve dense, compact bodies capable of absorbing immense pressure, with limbs adapted for short, powerful motions that conserve energy. Travel across the landscape would be deliberate and slow, guided by an intimate awareness of terrain and gravitational stress. As your awareness deepens, picture beings navigating rocky valleys, using vibration-sensing structures to read the land, each step chosen with care to maintain balance in an unforgiving gravitational world. Here, mobility becomes a form of resilience, a quiet testimony to life's ability to adapt under extraordinary constraints. In aquatic or fluid-rich planets, movement might resemble the graceful flow of currents rather than locomotion as we know it. Creatures would rely on buoyancy, subtle pressure changes, or rhythmic pulsations to navigate through dense, layered oceans. Some species might build organic vessels, extensions of their own bodies that harness chemical gradients or thermal vents to propel them over long distances. As your thoughts drift further into stillness, imagine vast migrations unfolding beneath thick layers of ice, guided not by stars, but by magnetic fields, chemical signals, or deep planetary resonances. Travel becomes a journey through darkness, illuminated only by bioluminescent trails and instinctive memory. On planets filled with dense vegetation or labyrinthine geological formations, mobility could evolve into specialized climbing, tunneling, or threading behaviors. Creatures might weave through complex root systems, carve tunnels through porous stone, or traverse towering mineral forests. Some civilizations could develop biological tools, symbiotic organisms that act as living harnesses, bridges, or transportation companions. These travel systems would arise not from external machinery, but from deep ecological partnerships, turning movement into a collaborative act between species. The landscape itself becomes a woven pathway shaped by generations of adaptation. For technologically advanced civilizations, mobility might transcend physical constraints entirely. Imagine beings who harness electromagnetic fields to glide across their planet, using subtle shifts in polarity to lift and propel themselves forward. Others might manipulate atmospheric currents or thermal gradients with precision-built constructs that merge seamlessly with their biology. As your awareness sinks even deeper, picture cities connected by luminous pathways, streams of energy, or pressure waves that carry travelers silently across continents. In such worlds, transportation becomes a blend of engineering and nature, guided by an understanding of physics far beyond our own. And as your consciousness settles into a soft, soothing calm, consider how movement, whether slow, soaring, fluid, or technologically enhanced shapes, not only the bodies of alien beings, but the structure of their societies, cultures, and histories. Somewhere across the universe, life may already be gliding through thin skies, climbing across crystalline forests, drifting through endless oceans, or traveling along invisible highways of electromagnetic force. In these diverse ways of moving, we glimpse the infinite creativity of evolution and the boundless possibilities of worlds we have yet to meet. Across distant planets illuminated by unfamiliar suns, the pursuit of knowledge would shape civilizations just as profoundly as biology or environment. As your breath softens into a slow, steady cadence, imagine beings whose senses extend far beyond human limits, creatures capable of perceiving electromagnetic spectra, chemical gradients, or seismic whispers with extraordinary detail. Their earliest sciences would emerge not from abstract curiosity, but from the careful interpretation of these natural signals. Over time, they would build frameworks of understanding that reflect their unique sensory experiences, crafting laws of physics and chemistry, guided by phenomena that remain invisible to human eyes. Knowledge, in such worlds, becomes an intimate dialogue between species and their environment. Technological development in these civilizations would follow paths influenced by the resources and constraints of their planets. On worlds rich in conductive minerals, early technologies might revolve around electricity and magnetism, shaping societies fluent in manipulating fields and currents long before mechanical devices appear. As your awareness deepens, Imagine laboratories carved into crystalline caverns where scientists grow magnetic structures like living sculptures, using them to map planetary rhythms or store vast amounts of information. Technology evolves organically, guided by the materials and energies that define the planet's identity. In underwater or high-pressure environments, scientific discovery might rely on the detection of vibrations and flows rather than light. Researchers could navigate vast oceanic chambers, tracing currents that carry chemical signals across continents. Their instruments might include living organisms engineered to react to specific compounds or pressure changes, forming biological sensors that expand the civilization's understanding of its world. As you drift deeper into calm, picture schools of symbiotic creatures acting as mobile laboratories, gathering data from distant regions and returning with observations encoded in bioluminescent patterns. Civilizations built on collective intelligence or shared consciousness would approach science in a manner entirely foreign to human thought. Their discoveries might arise from synchronized cognitive processes, allowing them to solve complex problems rapidly by distributing tasks across many minds. Imagine research gatherings where participants connect through electromagnetic pulses or chemical exchanges, merging insights in real time. The result is a scientific culture without individual ownership of ideas. Knowledge flows continuously, shaped by countless contributions that blur into a single, evolving stream of understanding. Exploration beyond their homeworlds would depend on their mastery of local physics. Some may develop spacecraft propelled by chemical reactions or nuclear energy, similar to humanity's efforts. Others might exploit gravitational slings, magnetic fields, or exotic materials unique to their planet. As your thoughts fade into deeper stillness, imagine starships shimmering with adaptive skins that change composition depending on cosmic radiation, or vessels that travel through liquid-like atmospheric layers of gas giants, gathering data from storms larger than entire continents. Each civilization's curiosity pushes it outward, guiding it into the darkness with a relentless desire to understand the universe. And as your consciousness settles into quiet, consider how deeply science and discovery would shape these alien societies. Their technologies, knowledge, and philosophies would reflect the landscapes they inhabit, the senses they possess, and the challenges they overcome. Somewhere across the cosmos, civilizations may already be measuring starlight in ways we cannot imagine, mapping gravitational pulse networks, or decoding chemical narratives written across ancient seas. In these distant pursuits of knowledge lies the shared truth that intelligence, wherever it emerges, seeks to explore, understand, and illuminate the mysteries of its universe.